Wow. You know what? This is the last chapter of the whole chemistry. You guys have been with this thing all year long, and I have really enjoyed having you. It's been absolutely amazing. And we're going to finish with biochemistry. And you know, biochemistry, just looking at the prefixes, the biology and the chemistry. So we're gonna take. I also teach human anatomy and physiology, so I love this combination because so if you need to take human anatomy and physiology 1 and 2, we offer that. I'd love to have you there. But we get into this in a lot of detail. But chemistry tells us what's going on. Okay. So for example, I'm going to give you. Today we're going to talk about, in the first video, we're going to talk about carbohydrates, proteins, and lipids. And the biologist is going to tell you a carbohydrate is sugars and starches and it's quick energy, okay? And that's good, and that's what we need to know. But the chemist is going to tell you, okay? The chemist is going to tell you, here's the structure and here's why it works, and here's why it works in our body, and here's how it makes water, and here's why we have to have it. So I think in biology it's great. I think we have to understand a lot of things, but I think in chemistry is where we see it and we go, oh, now I see why it works. Okay, so carbohydrate. Okay, so then we have a basic formula for a carbohydrate. A carbohydrate is a carbon, and you'll see that carbon, hydrogen, and oxygen make up about 98% of the human body. Carbon, hydrogen, and oxygen. Nitrogen's next. Let's see why. Okay, so a carbohydrate, this is the basic formula for every carbohydrate. Carbon, and then what do we have here? We've got a polar bond, bent, okay? Double bond oxygen and a hydrogen. And then we say we have an R group. So what that means is you'll see this all the time, especially when you get into upper chemistry, okay? You have an R group, which means that there's a Latin word, okay? R. The English word, the best we could come up with, is the rest of the compound. Okay, so that kind of help you. This is R is like the rest of the compound. There's nothing magic about R. It's just telling you that it has to have this and then the rest of the compound. So let's go a little bit further. Okay, so this is a carbohydrate. All right. Well, let's look at this. Here's a typical carbohydrate. Okay, glucose. All right, glucose. Well, glucose is found in photosynthesis, and if we don't have glucose, we don't live. We don't survive on this planet. Our bodies don't work. We absolutely positively have no life without glucose. Okay? So what do sugars do? What do carbohydrates do? They produce quick energy. They break down chemically. They unzip and form water and energy. They form water and they form energy. So how does that happen? Well, okay, here's glucose right here. Okay, so here's a glucose molecule, C6H12O6. Oh, so let's see. Okay, so here's our basic structure for a carbohydrate. You see that? See, R is the rest of the group. Okay, all right. The carbon, hydrogen, oxygen. The tip of this tells me, as a chemist, I look at that molecule and I say, hey, that's a carbohydrate. Well, that's cool. So then I say, okay, so this one's glucose, so it's 6 carbons. So the rest of the group here is, so we got 6 total carbons. 1, 2, 3, 4, 5, 6. Well, look at glucose. Glucose is critical, okay? Glucose is critical. Now, we have other sugars, okay? We have other sugars involved in life. There's no doubt about it. But whenever we have photosynthesis, okay, whenever we have photosynthesis, 6CO2 plus 6O2 makes C6H12O6 plus O2, okay? All right, photosynthesis, you learn that. If you've had biology, you know that, okay? But look what we've got. This is fascinating. So as this molecule breaks apart, okay, so look, we have the OH and the H back and forth, back and forth, back and forth. Now, is this a chiral molecule? Is it the same mirror image? No. It's non-chiral, okay, because this OH is here, but then it's over here. So it's not chiral. So what does it do? It's exactly like the zipper on your jacket. It's exactly like the zipper on your jacket. Isn't this amazing? Well, maybe you've heard of this compound, okay? Maybe you've heard of this compound. But what can we make with 2 hydrogens and an oxygen? Cool. Look what we're going to give off. Water. Oh. So the minute this water is given off, boom, we begin to break these chains and we get energy. Quick energy. And then what do we give off over here? Another water. Boom, boom, quick energy. And it just starts unzipping. And that glucose goes through and it makes that energy. And it makes energy and it produces water in our body. Win-win situation. We have fuel, we have oxygen, we have water. Glucose is so honking healthy. Now, what if we get too much glucose? What if we get, and we're going to talk later about polysaccharides, because regular glucose, okay, is not the sugar that we eat when we go eat candy and we put cups of sugar in there. That's a form of glucose, but it's a polysaccharide where we put a lot of sugars together so that we get a really sweet taste. Well, this works really good if we can do what? If we can break it down and we can make the water. If we can't break this down and we've got more glucose in our body than we know what to do with, then it builds up and we can't get rid of it. So how do you suppose we stimulate the breakdown of sugars in our body? We drink water. Wow. And as we drink water, we create more water, it pulls in more water, and you'll be like, oh, would that saturate it? No, it actually causes a reaction to continue even faster. Water breaks down sugars. Isn't that amazing? So there's carbohydrate, okay? So what might you need to know on your test? Well, I don't want to go over the test because I haven't even made the test up yet, okay? But you're definitely going to need to know the main formula for a carbohydrate. We might need to know something about glucose here, but we really need to know that what does a carbohydrate do? Produces quick energy. Produces quick energy. Okay, now let's move on to a protein, okay? Let's move on to proteins. And once again, these are chemical structures in the body that we have to have. We've got to have carbohydrates, okay? And we need a good combination of carbohydrates. Too many carbohydrates are bad. Not enough carbohydrates is bad. So now we've got another R group here. The rest of the molecule can be as many carbons over here as we want to have, okay? So now, look what we have here. It's a carbon-carbon bond, okay? Now look, isn't this interesting? This is very much like this, except it has an OH and an O. Well, what's an OH? An OH is an alcohol. Remember we had that earlier. So here's our deal. Carbon-carbon, OH and oxygen, but then we have an NH2. Now, NH3 we learned earlier is ammonia. So this is close to ammonia, but it's not a true ammonia, okay? It's ammonium, has an ion to it, okay? So it's NH2, and then we have an H, and then the R group, which tells us what? That this protein can be chicken, it can be beef, it can be all these different things, and that determines on the R group coming across how easily the protein breaks down. If it's beef, if it's chicken, if it's now. We have other proteins that are found. We have other proteins that are found in beans. We have proteins that are found in all kinds of other substances. So they may be shorter carbon chains that break down easier. Now, why do we have to have proteins? Okay, the reason we have to have proteins is right here. All right. Later on, I'm going to show you that to make RNA and DNA, we have to have a nitrogen base. Okay. So the only place we get nitrogen is right here in proteins. So what does it do? It's commonly in meats, but it's not just in meats. But what do proteins do? They make new cells. That's why somebody that wants to grow a lot of muscle, okay, or really wants to even grow in size, or even a little baby, we've got to, as soon as they get off of the milk, then we begin to get to proteins, because the mother's milk gives a ton of protein. And as soon as the baby gets off of the mother's milk, then we begin to come in with proteins, because proteins, well, make the new cells. If I'm a weightlifter, okay, you hear these people all the time taking whey protein and they put extra protein in. Why do they put extra protein? So the new cells can form. If there's no protein, then the new cells don't form. Can you imagine a third world country where they're starving and they don't have any proteins in their diet? Then as they begin to develop brain cells, they don't happen. Okay, or muscle cells, or tissue cells, so what do proteins do? They make new cells. So you need to know the basic structure of a protein. Remember, this R is just the rest of it. Okay, so that's proteins. What do they do? Make new cells. Okay, now let's do lipids. Now lipids are fats. Okay, lipids are fats, and they kind of get a bad rep, but they're pretty important. So here's the basic structure for a lipid. Okay. carbon, oxygen, carbon, okay? And carbon, oxygen, carbon. And then look, we have a double bond oxygen here and a double bond oxygen here, and then an R group. So that fat is going to come off here and going to have all these different carbons, okay? So that's going to be the R group. So now we have different kinds of fats, all right? Now, of course, these are just hydrogens on this side. Now, look what we have here, okay? H2 what? O, H2O. How do we break down fats? Water. And how do we stimulate this in our body? We have to have water. You know, we just don't drink enough water. You know, 4 or 5 glasses of water a day, they say is really minimal. You need like 8. And you're like, no, but I drink, you're like, no, but I drink Cokes and I drink tea and I drink all this other stuff. Yeah, but your water is stored up in the form of carbohydrates, so that water is necessary to break down the sugars that are in the Coke. You may get some water value, but not as much as pure water. So what happens here, okay? So it begins to break down, and once again it unzips. Now, I'm not going to ask you about saturated fats and unsaturated fats and trans fats, but that has to do with how many bonds we've got, okay? If we've got a whole bunch of bonds here, then that's a very slow breaking down deal, and it stays in your body for a long time. This is where we begin to get plaque and cholesterol. We'll talk about cholesterol a little bit. So there's different fats. We no longer allow manufactured products to have trans fats. They can't even have them anymore. I remember I went to the store one day, and they had all these honey buns. And they were like a nickel a piece. And they were big, and I was like, oh, wow, man, those taste amazing. Well, I got to look at the reason they were selling them is because that next week the new ban went in for no trans fats. So I was looking at this honey bun, and this honey bun had like 23 grams of fat in it, okay? And then down below it said 12 grams of trans fat. Oh, that's awful. What does that mean? That means we got all these triple bonds in here that in order to get rid of that fat, we got to do what? We got to break down this bond, then this bond, then this bond, then we release the carbon. Then we got to break down this bond, then this bond, then this bond. We've got to do so much energy to get rid of the trans fat, so a lot of times we don't get rid of it. But they're long-term energy, and so but we have to have fats. There's a lot of vitamins, like vitamin D, for example, that actually absorb on these oxygens, and in this molecule, that are the only way that we can get that vitamin is through fat. So, all right, so we're going to stop with this video and pick up with the next one, but we covered the basic formula for carbohydrates. We talked about glucose, okay? The basic formula, and we said glucose produces quick energy. We did protein, which said makes new cells, and where's that? This nitrogen. Think about where that comes from. Cows, what are they doing? They're eating the grass. The grass has come from the ground. We had to put nitrogen in the ground. If we didn't have lightning, we had to put nitrogen in the ground. We have to eat grass or something, the beans or something. We have to get nitrogen from the nitrogen system that causes nitrogen fixation, using through the ground and using through grasses and plants. Okay? So proteins make new cells. And then lipids, what do? Long-term energy. And I'm not going to ask you about the saturated and unsaturated, but you do need to know the basic formula for lipids. All right. See you on the next video for biochem.